All right, so we're going to start 2017 for your response questions. We'll start off with number one. Number one says, researchers studying a pack of gray wolves in North America collected data on the length, x, in meters from nose to tip of tail, and the weight, y, in kilograms of the wolves. A scatter plot of weight versus length revealed a relationship between the two variables described as positive, linear, and strong. So you can kind of imagine what this looks like. I don't know exactly what it looks like, but it's going to be something where as the length from the tip of their nose to their tail increases, the weight increases. So basically, if they're bigger, they weigh more. That kind of makes sense. And strong positive, something like this, right? So how do we describe this? And this is something that's a little tricky for students sometimes. So for the situation described above, explain what each means. So these are my interpretations. Positive. I wrote for positive means that as the length increases, the weight generally increases. And generally is an important word because it doesn't always happen, but generally the pattern is positive. Generally as length goes up, weight goes up. Linear, as the length from tip to tail increases, the weights increase consistently, right? If it wasn't consistent, it would be a different type of model, like exponential or something like that. Then, strong. The scatter plot doesn't contain any points that greatly vary from the positive linear pattern, right? Because if it was strong, if it were moderate or weak, there might be a point, and if you look up top, like there or there, that varies, but we don't have any of that because it says it's strong. Now, part B, interpret the meaning of the slope of the least square regression line in context. So they give you the equation here. It says y hat equals negative 16.46, that's the y-intercept, when x is 0, that's the weight, predicted weight, plus 35.02x. So interpret the slope is 35.02, and make sure you use context. As x increases by 1, or as the length from tip to tail increases by 1 meters, we expect their weight to increase by 35.02 kilograms. We expect, or we predict, has to be included. Now, part C I'll do with you guys. Part C says, one wolf in the pack with a length of 1.4 meters had a residual of negative 9.67. What was the weight of the wolf? So first, let's find out what the predicted weight is. So predicted weight equals this equation. So I'm going to plug in for the length 1.4. So we get the predicted weight, negative 16.46 plus 35.02 times 1.4 meters. And that tells me that their predicted weight is going to come out to, and I did this in advance, 32.568 kilograms. So that's their predicted weight, right? How do we find a residual? A residual is the actual minus the predicted. So knowing that, well, the predicted weight we know is 32.568. The residual, they tell us, is negative 9.67, which means that the predicted weight was much bigger than the actual weight. So how do we solve that? Well, we just solve this for actual. We are going to add 32.568 to each side. And we're going to get the actual weight, and it solves to 22.898 kilograms.